Hello everybody. In these exercises we're just going to be comparing a sphere with radius r to the volume of the figures depicted. Now for number 1 here, if I want to compare this to a sphere, I have a hemisphere, so I have to get that formula, and that is half of a sphere, 4/3 pi r cubed, but my r is different. My r is 2r as opposed to just regular 1r. Now we'll work on simplifying this. 2 cubed is 8. 8 times 4 is 32. And we have 6 on the denominator times pi r to the third. And 32 over 6 is going to reduce to 16/3 pi r cubed. Now if we compare that to 4/3 pi r cubed, we can obviously mathematically that the hemisphere is bigger. That volume is bigger. Okay, for number 2, looks like we have a cylinder. Volume of cylinder is pi r squared times height. Well, in this picture, the height is the r, and the radius is r divided by 2, which is being squared. Alright, so that gives us 1/4. Pi over the over 2 part here gets squared, becomes a 4. Got pi, and then r squared times r, I have an r to the third. Obviously the sphere is bigger in this case. 4/3 is bigger than 1/4. For number 3, we have a cube with a side length of r, and the volume of a cube is length, width, height, they're all the same to the third power, so it's just r to the third. Now over here, the sphere, I have 4/3 times pi. 4/3 times pi is going to be bigger than this constant of 1. The sphere wins this round too. Sphere has a bigger volume. Number 4, I have a rectangular prism. Let's figure out the area of the base here, 3r times r. Then we multiply it again by the height r. So now we have 3r to the third. 3r to the third is not as big as 4/3 pi r to the third. The sphere wins this round. It has a bigger volume. Number 5, looks like we have a cylinder again. Cylinder has a diameter of 3r. That means the radius would be 3/2 times r. Now volume of a cylinder, pi radius squared times the height, and the height happens to be another r here, but inside here we have 3r to the second, and I'm squaring that to get 9/4. Still have pi, and then r to the third, r squared times r. And 9/4 pi times pi compared to 4/3 times pi, the cylinder, it does win. It is a bigger value. And a way to check that, you could test it in the calculator and see what's a bigger volume. Without a calculator though, that's worth looking at. We need a common denominator. The common denominator is 12. This becomes 16/12. And then compared to this, which would be 27/12. So finding common denominators between 9/4 and 4/3, we do still see that 9/4 would be bigger. 27/12 is bigger than 16/12. Lastly, we have this hemisphere, 1/2, 4/3 pi, and the radius squared to the third power. The radius, however, is 2a. Now 2 to the third is 8. 8 times 4 is 32. So we have 32/6 again, a to the third. Now here it's really kind of hard to compare this. We have 32/6, which would be bigger than 4/3, just like in number 1. The thing we don't know is what is a and what is r. Those are two different variables. There's nothing guaranteeing one is bigger than the other. So we'll say on this one we just can't tell. And there we are.